So yesterday we found out how you could use the determinant to help you find an inverse of a 2 by 2 matrix. And we found out that the determinant has to be something other than 0 in order for an inverse to exist. Today we're going to look at 3 by 3 systems of solving them with matrices, and we're going to be using our calculators. So yesterday when we did 2 by 2s, at the end you were kind of like, I still think it's faster to use our old techniques of substitution and elimination to figure them out, but we figured out how to do them with matrices as well. With the 3 by 3s and a calculator, things can get a lot faster. So, I don't want to go there. Is this one next? I think that's the next slide. So just a review of finding the determinant of a 3 by 3. This is where we rewrote the first two columns. Had 3 diagonals going this way, so that would be 10 plus 6 minus 8, and 3 diagonals going this way, 60 plus 1 minus 8. This one would be subtracted, so you're going to get 8 minus 53 negative 45. And since the determinant is not equal to 0, we would know that an inverse exists for this matrix. Now there is a way to do it without a calculator. That's nice and complicated and too long for us to do without a calculator. So what we're going to do is we're going to find it with our calculator. For this first question, though, it says find a value of x for which the inverse does not exist. Well, we're going to have to use the idea that the inverse doesn't exist if the determinant in this matrix is P is equal to 0. So if we find the determinant of this one, and again, I'm going to rewrite the first two columns. Attempt to rewrite the first two columns. And in this diagonals, we will get 0 plus 4x minus 2. And with these arrows, we will get 0 plus x minus 16. That would be our determinant. And the inverse doesn't exist if the determinant's equal to 0. So if we set this equal to 0, we can solve for x and find out what value would do that. So combining like terms here, 4 minus x would be 3x. Negative 2 minus a negative 16 would be plus 14 equals 0. And we would get, if x were negative 14 over 3, then the inverse wouldn't exist. But for any other value of x, we would have an inverse that we could find. So in this question, we're going to use our calculator. So what we do is we go to our matrix and we type in 1, 2, 0. So I'll do that right now. Negative 2, 0, 1, 1, 3, 4. In matrix B, we can type in that other one as well. Second matrix. Edit. 3 by 3. I'll put A into A and B into B. 1. You're good. Anybody else need a calculator? And part 1 says use the calculator to find A inverse. Well, to find the inverse now, whoops, go back to my calculator. I can just go second matrix. I can type in A. I didn't want to type in A there. Get out of this screen. Second matrix, type in A, and then go inverse button, push enter. And we get a bunch of decimals. If I don't want the decimals and would prefer fractions because I could see them better, I can hit my math button and change my answer to a fraction. And I get all of these values. Could you see that I could factor a 15 out in front if I wanted to? Or factor out a 1/15 to make it nicer numbers? Oh, perfect. So now we have matrix A and we have matrix B, and we want to find matrix P. And A is a 3 by 3. We want to multiply it by something P, which we don't know, and it's equal to B, which is a 3 by 3. How big is P? It has to be a 3 by 3. The middle numbers, in order for the multiplication to work, would have to be a 3. And in order to get an answer that's a 3 by 3, we would need a 3 on the end as well. Now, if these were numbers, if it was 2 times P equals 7, you would just divide by 2 to get P by itself. But we don't have dividing in matrices. The only thing we have in matrices are inverses. And if you multiply by an inverse, you get an identity matrix. And an identity matrix is like a 1. When you multiply anything by 1, it stays the same. So we can get rid of this A if we multiply by A inverse. So if I multiply this side by A inverse, the A inverse times the A will equal to 1. I also need to multiply this side by A inverse, and this is something that's particular for matrices. Since I multiplied in the front over here, I'm going to need to multiply in the front over here, because the order of multiplication matters. That tells me that P should equal A inverse times B. And again, we can go to our calculator. We can write that A inverse multiplied by B and we find the answer for P 131, 0, negative 1, 2. Negative 2, 1, 0. So according to this, A, which is 1, 2, I'm just going to write this out. A times P equals B. A, which is 1, 2, 0, negative 2, 0, 1, 1, 3, 4. And P, which we just figured out to be 1, 3, 1, negative 2, 1, 0. Okay, matrices are good to check your memory capacity. Apparently my memory capacity is 6 numbers, because I could remember 6 numbers before I had to look again. I should work on memorizing 9. I could do this question better. And it's supposed to equal B, which is 1, 1, 5, negative 4, negative 5, negative 2, negative 7, 4, 7. Let's check if that negative 4 is right. How would I find out if that negative 4 is right? I'd have to multiply. Well, that negative 4 is in row 2, column 1, right? That's its position. So if I want to check if it's right, I'm going to take row 2 and column 1. Whoa, I almost got column 1. There we go. Perfect. If you multiply those together and add, does it give me negative 4? Good. Let's check this 4 right there. Can you see that that's in row 3, column 2? So if I wanted to check it, I would have to take row 3, column 2. Something doesn't look right, does it? Row 3, column 2, 1, 3, 4. That should be 0. But it says 4. What went wrong? Did everybody get the same answer that I did down here? Negative 2, 1, 0. Did I write something? Oh, I can't even remember. So there we go. What I said about being able to memorize 6 numbers is now been negative 2, 1, 0. Apparently I can only memorize 1 number at a time. Well, I can memorize 3 numbers, just can't keep the order.
What's the order of 1, 2, 3?
Well, I should work on that. But let's see if it works now. 1, yes, it does match up now. So if you're checking and you write the numbers down wrong, it's a good chance that it won't work out for you. And you think that's frustrating. Wait till we do what's next. Because what we do next is you make 1 number wrong somewhere. It throws everything off. And you have to basically start over again. And then if you make a mistake somewhere else, it throws everything off. Okay. Well, we're not there yet. Solve the following system of equations using the inverse matrices method. Well, what we did with our 2x2s when we had a system of equations is we set up a matrix. So here's a matrix of our coefficients. In this case will be 1, 2, 3, 1, negative 1, 1, 2, 1, 1. A matrix of our variables and make it equal to a column matrix of the answers. And I'm going to call this matrix A, this matrix X that I'm solving for, and this matrix B as our answer. I want to solve for X. Here, if we had to use substitution or elimination, it took a little bit longer. We've done these, right? The system where we eliminated one of the variables and then got 2 new equations and then did that again. It was a little bit time consuming. Now that we have our calculator, if I have the equation AX equals B, I could multiply in front by A inverse on both sides. And that would get me X all by itself. So once again, we're going to need to enter these matrices into our calculator. Matrix A was 1, 2, 3, 1, negative 1, 1, 2, 1, 1. And matrix B was a 3 by 1, 3, 2, 8. And once we have our matrices into our calculator, we can just go A inverse B. The nice thing is I have it typed right above me. So instead of retyping it, some calculators you can just arrow up and highlight it and push enter. And it will do that calculation again. Uh-oh. Invalid dimensions. So we have to check, did I type something in wrong in my matrices? Quit. Second matrix. Matrix A was a 3 by 3. How did I make it through? Oh my goodness. Did I just type, did I think I went to matrix B and type in? Oh. 3 by 3. Yes, there it is. That's matrix B. So I have to retype matrix A, 1, 2, 3. 1, negative 1, 1, 2, 1, 1. Second quit. Second matrix. Edit matrix B to be the 3 by 1. 3, 2, 8. And now when I go A inverse B, it should work. Another way to get what you typed before, because some of your calculators might not allow you to go up and highlight what you had before, is you can go second enter, and it will just retype your last entry. If you keep doing that, it will go back as far as you want, or as far as it has memory for. No error this time, and we get x equals 4, 1, negative 1. Which means x was x, y, z. We know that x is 4, 1 is, y is 1, and z is negative 1. Yes? Well, this would be, okay, you might not be able to tell from my writing, but this is a capital X, and this is a little x. In that sense, it's okay. Because we name matrices with capital letters, and the variables themselves would be with little letters. Now, depending on context, you might not be able to tell that one of them is a big X and one of them is a little x. But this one, doesn't it look bigger?
I mean, yes, but you can have a small, like, I can make a little capital A and a massive lowercase.
Yeah. But that would just look stupid. So.
Depends on the context.
Oh, would you mess kids up in grade 1 if you were, okay, here we go, let's practice these. Right? That would totally screw.
Wait, no, but now do C.
Oh. Just to mix things up. And then after that, you could go here and that kid would be really confused. Oh. There's a reason why I don't teach elementary school. You guys have at least developed some sort of resiliency that if I mess with your brains a little bit, you have time to recover. But I'd be afraid of those kids in kindergarten if they would ever recover